Good morning, students. In the today's class, we will start with a new chapter, that is haloalkanes and haloarenes. Right here, haloalkanes and haloarenes. Okay, what are those haloalkanes and haloarenes means? You know, alkanes means the formula CnH2n plus 2. Okay, haloarenes means the consist of a benzene ring. Haloalkanes means the formula CnH2n plus 2. This one is benzene ring. I'll take an example of this methane here. Okay, so hydrogen, hydrogen, hydrogen. Example for a one atom. Here I'll take benzene. Benzene formula is C6H6. This is CH2. So that means here hydrogen will be there. Correct? So what are these haloalkanes and haloarenes means? This is the arene group, aryl group. This is the alkyl group. Okay? So if any one of the hydrogen from alkane is replaced by halogen atom, then they are called as haloalkanes. Understand? So here what happens? The hydrogen of an alkane is replaced by the halogen atom, then it is the derivative of halogen with respect to alkane. Okay, this is haloalkane. If in case this group R group must be aryl. If any one of the hydrogen of the aryl group is replaced by halogen atom, then it is said to be a haloarene. If benzene ring is there, then it is called as haloarene. If alkyl group aliphatic compound is there, then it is called as haloalkane. Okay, what are haloalkanes and haloarenes means? The derivatives of the alkanes and aryl compounds in which at least one hydrogen is replaced by halogen atom. At least one hydrogen. Okay, so if two hydrogens are replaced by halogen means this is dihaloalkane. If 3 is replaced by triallo, 4 is replaced by halogen, tetraallo, like that. So example for that, you know, CCl4 is there, tetrachloromethane. CHCl2 is there, trichloromethane. CH2Cl2 is there, dichloromethane. CH3Cl is there, monochloromethane, and CH2. Cl what comes? Cl4 hydrogen is there. Each hydrogen is replaced by 1 Cl, 2 Cl, 3 Cl, 4 Cl. Okay, so these are all what? The derivatives of alkanes and arenes. How these derivatives will form? By replacing the hydrogen atom of the carbon with any one, at least one hydrogen with halogen atom. The halogen means what? The halogens are either fluorine, chlorine, bromine, iodine, whatever it is. Okay, so that is haloalkanes and haloarenes. In our daily life, we use most of the things, derivatives of haloalkanes and haloarenes in our daily life. Okay, so bleaching powder, you know, used to bleaching powder. So in bleaching powder, chlorine gas will evaporate, white color plus just decolorises the cloths. Okay, in that we use these halogen compounds. Okay, in anesthesia we use this compound, chloro compounds. Okay, so in detergents we use this. Understand? So in most of the things we use the haloalkanes and haloarenes. Understand? So in this, these haloalkanes and haloarenes are classified into different categories based on the nature of the carbon atom to which the halogen is bonded and the number of halogen atoms also. Okay, so next one is classification. Okay, In that classification, but first one is based on number of halogen atom. Based on number of halogen. So students, I'll take here. First I'll take haloalkane. Next I'll take haloarene. Okay. So here, if I take example of CH3, CH2, Cl. Okay. So this one is mono chloro. Two carbon atom means the suffix is eth. All are single bond means ethane. Monochloroethane. Okay. So instead of that you take CH3 or CH2, Cl, CH2, Cl. Here two chloride atoms are there. At which position? Instead of Cl, you may take Br also. 1, 2 position you take 1, 2 dichloroethane. Okay. If you consider one carbon atom is there, that is CH3 is there, CH, Cl, Cl, CH2, Cl. Consider there may be a chance of possibility of a compound like this also. This is 1, 2, 3. Okay. At 2 position and 1 position. 1, 2, 2 trichloro. Here 1, 2, 3 carbon atoms is there. That is propane. Okay. So here this parent chain remains same. Ethane, ethane, propane. But here they classified based on what? Number of Cl atom. So this is monochloroethane. This is dichloroethane. If you consider instead of this, you take CH2, Cl, CH, Cl, Cl. Okay, that is 1, 2 trichloroethane. Okay, friends. In all these things, this parent chain ethane remains same. Only the thing changes here: monochloro, dichloro, trichloro. This is one type of classification based on what? Halogen atom. This is in what? Haloalkanes. If we consider it for same haloarenes, if this is a benzene ring, okay, here Cl is there, then this is chlorobenzene. Okay, if to the same benzene ring, 2 halogen atoms are attached, then this is dichlorobenzene. Okay, if to this same 3 halogen atoms are attached, like Cl, 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 then it is trichlorobenzene. Here also parent chain remains same, only the thing is number of halogen atoms. So here at 1 position is there, nothing we have to worry about that. This is chlorobenzene only. But with respect to this is first, this is second, this is third. Means 1, 3 dichlorobenzene. With respect to this is first, second, third, fourth, 5 and 6. That is 1, 3, 5 trichlorobenzene. Don't consider Cl only the stable compound. So like I am using only Cl means, okay. You can take Br also, you can take I also. Okay. So for your convenience, I take this such a difference you can see easily. Okay, so this is classification based on number of halogen atom. This is classification of haloalkane. This is classification of haloarene. Okay. Next one is based on nature of carbon atom to which halogen attached. Okay, based on nature of carbon atom to which halogen is attached. In the first one, sp3 hybridized carbon atom. If the halogen is attached to sp3 hybridized carbon atom. So in haloalkanes, how it is classified? So listen, I'll take one example. This X, this is H, H and H. Okay, this one is simple alkyl group. Okay, alkyl or haloalkane alkyl halide. Okay, students. If in this only mono haloalkanes we are taking, mono haloalkanes, because in dye we cannot classify primary, secondary and tertiary. Okay, in mono haloalkanes we can classify in haloalkanes. Okay, so we are taking example of mono haloalkane, especially methane. Okay, so this is one type of alkyl. Next, if you take this carbon is attached to two carbon atom. So the carbon atom to which CH is attached, if it is attached to one hydrogen atom only, then it is alkyl. If this carbon, this is attached to one carbon and two hydrogen, means the carbon further attached to another carbon, then it is primary alkyl halide or primary haloalkane. Okay, primary alkyl halide you may say or primary haloalkane you may say. I'll write here only. Haloalkane. This is primary haloalkane. Okay. Next, this carbon. Okay, which is attached, the carbon to which halogen is attached, which is further attached to through two carbon atom. If this carbon attached to one carbon, then it is primary. If this carbon to which halogen is attached, if it is attached to two carbon atom, then it is secondary haloalkane. Secondary haloalkane. Similarly, this benzene ring is there. Sorry, not benzene ring. Carbon to which halogen is attached. If it is further bonded to three carbon atom, then it is tertiary haloalkane. Understand? So from that you can easily say this one is, you may write alkyl halide also. This is primary alkyl halide. This is secondary alkyl halide. This is tertiary alkyl halide. That is a common. This one is IUPAC name. This one is common name. I'll explain while explaining nomenclature. Okay. So what happens in case of haloarenes? Okay. Students, in haloarenes, benzene ring is there, double bond is there. Correct? If this benzene ring is there, if it is attached, X atom is there, if it is replaced by any C atom, then this will not be a primary, secondary and tertiary. Again it comes to what? This haloalkane group. Because the carbon which is already bonded to the carbon atoms only here, it is the benzene ring. So in these haloarenes, we cannot classify them as primary, secondary and tertiary. And at the same time, if one carbon atom is there to which we cannot bond 3 aryl groups. We cannot bond 3 aryl groups because these are bulkier groups. There is a repulsion between these two molecules. That's why we cannot replace any R group which is aryl group to the one carbon atom in the same compound to explain it as a primary, secondary and tertiary. Here also in that to the one carbon atom in the same compound to explain it as a primary, secondary and tertiary. Here also in that to the same carbon atom, 2 carbon atoms is always attached in the benzene ring. Okay, if it is attached to another carbon, this becomes the tertiary. Here this is carbon atom to which carbon attached to which X attached means it is always secondary only. So we cannot distinguish primary, secondary, tertiary in this haloarene. So the primary, secondary and tertiary carbon atoms, especially in the sp3 hybridized carbon atom. Okay, that is only we can explain in haloalkanes. That is for what? Primary, secondary and tertiary. But in benzene, there is one possibility is there. Okay, so listen. One benzene ring is there. Next, another carbon to which X is attached. To the carbon sp3 hybridized which is attached to the sp2 hybridized. Okay, here this is sp3 hybridized carbon atom attached to what? sp2 hybridized carbon atom. So of benzene, then it is benzylic halide. Benzylic halide. So instead of this, if we take CH2 double bond CH, single bond CH2X. If the sp3 hybridized carbon atom which is next to the sp2 hybridized carbon atom, sp3 hybridized carbon atom which is next to the sp2 hybridized carbon atom in aliphatic compound, not aromatic. In aliphatic compound, then it is allylic halide. Understand? So here what you can say easily, here in these area hydrogen atom is attached to what? sp3 hybridized only. Here it is directly attached to sp3 hybridized carbon atom, then it is classified as haloalkane, primary, secondary and tertiary. Okay, if it is attached to the sp3 hybridized carbon which is further attached to sp2 hybridized. If sp2 hybridized is benzene ring, then it is a benzylic halide. If it is a aliphatic, then it is a allylic halide. So total 5 classifications are based on number of halogen atom, mono, di, tri, tetra, etc. Based on sp3 hybridized carbon atom, primary, secondary, tertiary, benzylic and allylic. Understand? Primary, secondary, tertiary, benzylic and allylic. These primary, secondary and tertiary students, it is very important throughout organic chemistry because the stability, their reactivity, their acidic character, basic character, everything explained on the basis of primary, secondary and tertiary character of the compounds. For example, you know, carbocations are there, plus ions, right? If you want to explain the stability of these carbocations, primary, secondary and tertiary is greater than secondary, greater than primary. Means tertiary is more stable than primary. If you consider negative ions, then primary is greater than secondary, greater than tertiary. Okay, like that to explain the stability, their reactivity, their order, this one is very important. Understand? In sp3 hybridized carbon atom, 5 classification we studied: primary, secondary, tertiary, benzylic and allylic. Okay, this is one type of classification. Next one, next one is if it is attached to sp2 hybridized carbon atom. Okay, if it is attached to sp2 hybridized carbon atom. For example, I take CH2 double bond CH X. Okay, this is sp2 hybridized carbon atom. If the halogen directly attached to sp2 hybridized carbon atom, then it is vinylic or vinyl halide or vinylic halide. Vinyl also you can say vinyl halide. This is in what? Haloalkanes. If it is directly attached to what? sp2 hybridized carbon atom. Okay, if it is directly attached to sp2 hybridized carbon atom in the benzene, here all are sp2 hybridized, correct? sp2, sp2, sp2. Then this is aryl halide, or you may also write it as arylic halide. Understand? So this is the classification of haloalkanes and haloarenes based on nature of carbon atom. Total 7 type of classifications. 7, 8 types. So another one is there based on halogen atom only, but to which the halogen atoms are directly attached. So in that, what is the classification means? So listen, here I'll take example. So students, here Cl is attached to assume. If if the halogen atoms in a dihalogen compounds, I am telling, okay, if halogen compounds attached to the same carbon, then they are called as geminal halides. Geminal dihalides. If the halogens are attached to the same carbon, two halogen atoms attached to the same carbon atom, then they are called as what? Geminal halides. Similarly, another one is CH2 is there, single bond CH2, here X, X. If the halogen atoms are attached to the adjacent carbon atoms, adjacent means 1 by 1, then they are vicinal halides. Vicinal dihalides. This is one classification. Understand? If the carbon atom is sp2 hybridized to which X is attached, means halogen is attached, then that is vinyl halide. If in a benzene ring it is a halogen atom is attached, then it is aryl halide. If the two halogen atoms are there which is attached to the same carbon, then it is geminal dihalides. The two halogen atoms which is attached to the adjacent carbon, it must be adjacent, not like this CH3, CHCl, CH2, CH2Cl. This is not vicinal. Because here these two are not adjacent carbon atoms. Understand? If instead of this, if it is here, then this is the vicinal. Understand? The halogen atom should be attached to adjacent carbon atoms. Then it is what? Vicinal. If it is attached to the same carbon atom, then it is geminal dihalide. This is classification in what? Dihalides. Understand? So this is all about the classification of haloalkanes and haloarenes. Okay? I'll write it in one chart form, you can easily write. So listen, you consider here haloalkane. This one is haloarene. So in this first one classification, mono, di, tri, haloalkanes depends. Okay. Here also first classification, mono, di, tri, haloarenes. Correct? Based on what? Number of halogens. You may easily understand this one. Monohaloalkane, trihaloalkane, trihaloalkane. Monohaloarene, dihaloarene, trihaloarene. If you want to write the example, you may write. Next, second one. This one is classified as primary, secondary, and tertiary. Based on sp3 hybridized carbon atom. You may write here. The first one. Based on halogen atom. Second, based on sp3 hybridized carbon atom. These are classified as what? Primary, secondary, tertiary, and allylic. So here, these are classified based on the sp3 hybridized carbon atom, that is benzylic. Third one classification based on sp2 hybridized carbon atom to which halogen is attached. This one is vinyl. This one is allyl. Understood? This is the classification. Another one is that there is geminal and vicinal. That is not necessary, but you have to remember. That is important for NEET and NEET examination. Understand, students? This is the classification. In that, the very important thing is these 7 classifications are very important for 1 marks. Understand? So next we will go the nomenclature of haloalkanes and haloarenes. Classification is done. Next one is nomenclature. Next is nomenclature. Okay, so right here, first one is structure. Next, common name means alkyl halide. Okay, next is IUPAC name. That is haloalkane. In the IU common name they called as alkyl halides. In the IUPAC name they called as haloalkanes. Okay, so I'll write one by one, students. Here I'll take the simple structure CH4, CH3, Cl. Okay. So in the place of halide, what is there? Cl is there. So if we want to pronounce it as halide, means this becomes chloride. So your alkyl group means CH3. One carbon atom means it takes methyl. Okay. This is methyl chloride. This is the common name. Okay. So in the IUPAC name,